Cruise Command speed control systems are available on all AMC and Jeep vehicles equipped with automatic transmission. However, there are two types of Cruise Command systems. All Jeep vehicles and pre-1978 AMC vehicles equipped with Cruise Command utilize the mechanical system. 1978 and newer AMC vehicles equipped with the Cruise Command option use an electronic system. As we'll see in this program, there are some important design differences between the two systems.
First, we'll cover the electronic system. We'll look at the individual components that make up the system, and we'll see how the system operates. Then we'll discuss some quick diagnosis and service procedures you can use when you're working on an electronic system. Essentially, the electronic system utilizes electrical signals, intake manifold vacuum, and speedometer cable input to maintain a speed that's preset by the driver. The components that make up the system are the control switch, the speed sensor, the regulator, the servo, the upper and lower speedometer cables, and a vacuum storage can that features an internal check valve. The control switch assembly is an integral part of the directional switch lever. The control switch assembly consists of two separate switches. One is the off-on resume slide switch, and the other is the push-button set switch. The road speed must be above 30 miles per hour for the system to engage. To engage the system, begin by moving the slide switch to the on position. To set your speed, simply press and release the set switch. The set speed will be maintained until you depress the brake pedal or move the slide switch to its off position. If you want to increase your set speed, accelerate to the desired speed, then push and release the set switch. To decrease your set speed, hold the set switch in until the vehicle has decelerated to your desired speed. Release the switch, and the lower speed will be maintained. If you have set the system at a particular speed, then slowed down again, you can use the resume feature to return to your preset cruising speed. Make sure that the vehicle is traveling at a speed above 30 miles per hour. Move the slide switch into the resume position momentarily, then let the switch return to its on position. The vehicle will now accelerate rapidly to your previously selected speed. The resume feature's memory is canceled when the slide switch is moved to its off position. It's also canceled when the ignition switch is moved to its off position. Some newer vehicles equipped with electronic cruise command also have an acceleration or accel feature. You can use this feature to accelerate to speeds above your preset cruising speed. For instance, if you want to accelerate to pass another vehicle, hold the resume switch in its resume position to accelerate around the vehicle. Then let the switch return to its on position. The vehicle will automatically return to your preset speed. Now let's look at the system's individual components. This is the speed sensor, which is connected to the upper and lower speedometer cables. The sensor converts speedometer cable revolutions into an alternating current electrical signal, which is then passed on to the regulator. The regulator is a sealed unit that's located under the instrument panel. Although there are external adjustments that you can make to the regulator, it is serviced as an assembly. It contains printed circuits, so if it's defective, the entire unit must be replaced. In a minute, we'll look closely at the roles of the regulator and the other components. The servo converts the regulator's electrical signal into motion. As we'll see, it uses intake manifold vacuum to perform this conversion. The vacuum storage canister ensures that vacuum is always on tap, even when engine vacuum is low. This is how the canister's one-way check valve works. On the left here, the engine is developing intake manifold vacuum. This vacuum is applied to the canister through the check valve. On the right, however, intake manifold vacuum is temporarily low, as it would be in an acceleration situation. The check valve is closed, trapping vacuum inside the canister. Now the servo still has vacuum available if it needs it. This cutaway reveals the internal components of the servo. As you can see, the heart of the unit is a diaphragm, which is under spring pressure at all times. There are two valves. One, the charge valve, admits manifold vacuum. The other, the vent valve, bleeds vacuum to the atmosphere. Both valves are controlled by solenoid coils, which receive an electrical signal from the regulator. Other components shown are the brake vacuum dump, the throttle chain, and the throttle position sensor. We'll discuss all of these components shortly. The regulator utilizes its printed circuits to perform a number of functions. Its first function is shown here. The amplifier portion amplifies and shapes the AC signal received from the speed sensor. The regulator then converts the AC signal into a DC signal that's proportional to the vehicle's road speed. This DC voltage is supplied to 3 circuits within the regulator. The first circuit to receive this voltage is the low-speed circuit, which is shown here. This circuit compares the DC voltage with a built-in standard that represents 30 miles per hour. The DC voltage must be above this standard for the engage and resume circuits to activate. When the driver depresses the set switch, the DC voltage is also supplied to the memory circuit. The memory circuit then produces 2 signals of its own. One signal represents the set speed plus 1/4 mile per hour. The other represents the set speed minus 1/4 mile per hour. These 2 signals are then passed on to the regulator's comparators. The comparators continually monitor the vehicle's road speed voltage to be sure that the speed does not vary more than 1/4 mile per hour either way. As long as the road speed remains between these plus and minus values, the throttle position will remain fixed. In order for the throttle position to remain fixed, both valves must obviously remain closed. The regulator must maintain a signal to the vent valve for it to remain closed. But the charge valve, which is designed differently, remains closed when it is not receiving a signal. Now the vehicle has encountered a grade and the road speed signal has dropped below the low comparator limit. The regulator must now signal the servo to increase the throttle opening. In order for the throttle opening to increase, the charge valve must also receive a signal from the regulator. When it receives this signal, it admits additional vacuum into the chamber, and the diaphragm and throttle chain are pulled to the right. The throttle position sensor prevents the diaphragm from opening the throttle too far. The throttle position sensor increases road speed voltage as the throttle opens. It increases this voltage until the voltage is back within the comparator limits. This action allows the system to operate as a closed-loop system in such a way that there is no overcompensation for decreasing road speeds. Once the road speed signal is back within the comparator limits, the signal to the charge valve is disrupted. The valve closes, and the diaphragm and throttle are fixed in a new position. Now the vehicle is descending the hill, and the road speed signal has increased until it is exceeding the high comparator limit. So now the regulator must instruct the servo to decrease the throttle opening. Remember that the vent valve remains closed as long as it receives a signal. To decrease throttle opening, the regulator disrupts its signal to the vent valve opens, and the vacuum is bled to the atmosphere. The diaphragm spring tension forces the diaphragm to the left, decreasing throttle opening. The throttle position sensor now prevents the throttle from closing too far by modifying the road speed signal until it's back within the comparator limits. Here's how the vacuum is dumped when the brake pedal is depressed. As you can see, the brake pedal vacuum dump operates completely independent of the regulator. When the driver hits the brake, two things happen. First, the regulator disrupts the signal to the vent valve. This causes the valve to open, bleeding the vacuum to the atmosphere. At the same time, the brake-operated mechanical dump switch bleeds the vacuum through the vacuum dump. This accelerates the release from the set speed. In the reference book that accompanies this film, you'll find the testing, adjustment, and other service procedures needed to properly service an electronic cruise command system. The reference book contains complete step-by-step instructions you can use to perform two important electronic cruise command circuitry tests, the control switch continuity test and the general circuitry tests. The reference book also contains instructions for performing two routine mechanical adjustments, the centering adjustment and vacuum bleed switch adjustment. Now let's examine the mechanical cruise command system. Here we'll also look at the individual components, theory of operation, and diagnosis and service procedures. The mechanical system also utilizes electrical signals, intake manifold vacuum, and speedometer cable input to maintain a preset speed. The components that comprise the system are the control switch, the relay, the bellows, the regulator, and the upper and lower speedometer cables. As you can see, this system is quite different from the electronic system. The control switch, though, is identical to the one used in the electronic system. It contains the same type of slide switch and push-button set switch. It also functions in pretty much the same way as the one used in the electronic system. To engage the system, be sure your vehicle speed is above 30 miles per hour. Put the slide switch in its on position, then depress and release the set switch push button. To increase your set speed, accelerate to the desired speed, then push and release the set switch. Here's one way in which this system functions differently. To decrease your set speed, tap the brake pedal, allow the vehicle to slow to your desired speed, then press and release the set switch. To resume a preset speed, again be sure that your vehicle speed is above 30 miles per hour. Move the slide switch to the resume position momentarily, then release the switch. The resume memory function is canceled when the slide switch is moved to its off position. It is also canceled when the ignition switch is moved to its off position. The regulator operates quite differently from the electronic regulator. It senses vehicle speed directly through the speedometer cable, and its internal components utilize more mechanical principles than electronic principles. We'll study each component more closely momentarily. The relay switch prevents the battery from being drained when the ignition switch is in its off position. As we'll see, the relay is engaged when the ignition switch is turned on. The bellows unit receives a modulated vacuum signal from the regulator. The bellows unit converts this vacuum signal to motion and controls the throttle opening through a beaded chain. The internal components of the regulator are subdivided into three functional groups: the governor assembly, the solenoid and valve assembly, and the coupling coil and centering spring assembly. The solenoid and valve assembly controls vacuum entering the regulator. The components of the assembly are the solenoid coil, a spring, the valve body, and a valve stem. The solenoid and valve assembly has two modes. On the left, the coil isn't energized. The reed switch is open and the valve is down, sealing off the vacuum switch. On the right, the coil has been energized and it has pulled the valve up off of its seat. The magnetic field that surrounds the energized coil causes the reed switch to stay closed. Now the coil is self-energized. The governor assembly features a pair of flyweights that rotate on a shaft driven by the speedometer cable. The centrifugal force forces the flyweights outward, initiating a chain of events that we'll follow in a minute. The coupling coil is the component that facilitates the memory function during the resume phase. The coupling coil is rotated on its axis by the governor actuator assembly. First, let's see how a 30-mile-per-hour prerequisite is built into the system. The flyweights move outward in response to the centrifugal force generated by a 30-mile-per-hour road speed. This movement forces the actuator to slide away from the flyweights against spring resistance, closing the low-speed switch. The actuator also opens the vacuum regulator port, which is shown here. This unit bleeds manifold vacuum to the atmosphere in response to the position of the actuator. When the coupling coil isn't energized, the vacuum regulator plate is held in its position by a centering spring. This system can be difficult to grasp, so let's look at the system in its various modes. Here we're driving along at a road speed less than 30 miles per hour. The ignition switch is on, so the relay is energized. Current is now supplied to the slide switch. We're still traveling at a speed less than 30 miles per hour, and we've moved the slide switch to its on position. Now current is supplied to the coupling coil, and the coupling coil is locked to the vacuum regulator plate. The solenoid coil is still not energized, though, so the vacuum valve is still in its down position, sealing off the vacuum source. Now we've exceeded 30 miles per hour and depressed the set switch to set the speed. The solenoid coil is energized and the current flows through the low-speed switch to ground at the stop lamp bulbs. The vacuum valve is in its up position and the vacuum is supplied to the bellows. When we release the set switch, the coupling coil and vacuum regulator plate are locked together and the vacuum port bleed size is established. Here's how the system corrects for decreasing road speed. The flyweights move inward and the actuator moves down the shaft. The vacuum bleed is now blocked, so full vacuum is directed to the bellows. When the vehicle speed begins to exceed the preset speed, the flyweights move outward and the actuator moves down the shaft, uncovering the vacuum bleed. The vacuum to the bellows is decreased, so the throttle closes. Here's how the system is disengaged when the brake pedal is depressed. The voltage that applies the stop lamps counteracts the voltage flowing through the solenoid coil. The coil is now de-energized. The valve closes, interrupting the vacuum to the bellows. Note that the coupling coil and vacuum regulator remain locked together. This facilitates the resume feature. When the slide switch is moved to the resume position, current is again supplied to the solenoid coil and the valve returns to its up position. The coupling coil circuit now continues to control the vacuum bleed per the previously set position. The film reference book also contains important service procedures pertaining to the mechanical system. There are 3 electrical circuitry tests you may have to perform: a general test, a release circuit test, and a relay test. As far as routine adjustments go, there are 2 you should be familiar with: the bellows chain linkage adjustment and the centering spring adjustment. Your most comprehensive sources of information on both cruise command systems are your Jeep and AMC technical service manuals. Also,
Be sure to attend the Cruise Command Service Training School when it's held in your area.